The industrial age replaced human muscle with mechanized labor. Then, the information age completely digitized the resulting data. Today's artificial intelligence largely operates as an advisory layer. It processes information and recommends actions, but a human must still click a button to execute the final decision. The emerging machine economy removes that human bottleneck, allowing software agents to take autonomous economic action. When an AI attempts to execute a real-world financial trade autonomously, it hits a wall. It is forced to interface with legacy banking APIs. These traditional systems require manual permissions, batch processing, and operate on human speed schedules. They are centralized bottlenecks designed for people, not algorithms. Human speed financial rails physically cannot support real-time, machine-to-machine coordination. Modern monolithic blockchains also struggle here. A single generalized network designed to handle everything from social media to decentralized finance cannot efficiently orchestrate enterprise-level AI activity. Autonomous commerce requires a specialized multi-chain stack. This stack relies on three highly specific pillars: a layer for decentralized rapid settlement, a system for verifiable data oracles, and an immutable log for consensus. True machine-to-machine commerce demands an interconnected architecture of specialized networks, rather than blind allegiance to a single blockchain. Before an AI can participate in an economy, it needs the ability to execute instant, predictable value exchange. The XRP ledger, or Xrpl, serves as the designated settlement layer in this architecture. This graphic outlines the infrastructure required for scale. Looking at the left column regarding speed, finality, and reliability, we see the contrast. While traditional market settlement takes 2 days, the Xrpl confirms transactions with deterministic finality in seconds. This diagram illustrates Xrpl access. On the left, the gas wars path shows wealthy users paying to front-run transactions, whereas Xrpl ensures fair, predictable costs. Moving up, Xrpl features a native decentralized exchange, allowing machines to swap assets without vulnerable third-party smart contracts. This chart illustrates the direct correlation between transaction overhead and network activity. When fees approach zero, high-frequency micro-apps and constant experimentation become economically viable for the first time. The Xrpl provides the friction-free, low-attack surface rails required for machine-scale execution. A settlement layer operating in isolation is blind. It has no awareness of external market conditions or real-world events. The Flare network acts as the sensory input for this architecture, providing verifiable external data to autonomous agents. The Flare time series oracle aggregates decentralized pricing data, feeding a single, verified asset price directly to the AI. Beyond pricing, the Flare data connector allows the AI to mathematically verify state changes on completely separate blockchains without trusting a centralized third party. Without verifiable oracles, autonomous financial agents act blindly. Data verification is as critical to the stack as the settlement itself. Corporate adoption of AI introduces a strict paradox. Businesses require mathematical proof of an AI's actions for compliance, but they cannot expose proprietary financial strategies or client data to a public blockchain. The solution is a system architecture known as verifiable autonomy. To maintain privacy, the AI executes financial strategies inside a secure hardware enclave, utilizing confidential computing. Simultaneously, the Hedera consensus service instantly records a cryptographic timestamp on a public ledger, proving the action took place without revealing the underlying sensitive data. Hedera provides the immutable audit trails necessary for institutions to securely engage in machine commerce. The architecture linking the Xrpl, Flare, and Hedera operates through the Denarii orchestrator. This operating system allows AI to manage autonomous treasuries, optimize capital deployment, and execute complex workflows across chains. This level of automation introduces a systemic challenge: governing a network that operates at machine speed using human community structures. Traditional DAOs rely on token-weighted voting and proposal bureaucracy. These slow, politically driven processes act as a liability for autonomous networks. This diagram illustrates action-based governance. Rather than voting, protocol direction emerges purely from usage. Notice the branching pathways. The most heavily utilized forks guide future creation, and successful code survives through utility. This graphic details the No Kings, Just Builders framework. Look at the progression from initiation to emergence. Influence within this system is earned exclusively by shipping functional micro-apps and tools, not by holding a large supply of tokens. Machine networks govern themselves organically through Darwinian utility, effectively eliminating human political overhead. Shifting away from speculative crypto tokenomics provides a massive strategic advantage. It anchors the network in actual utility rather than market cycles. This flowchart maps a self-reinforcing, closed-loop economic design. Contributors earn tokens for creating value, which are spent to access AI tools, funneling value back into ecosystem development. As highlighted below, platform usage creates organic demand, completing the loop independent of market hype. Sustainable machine economies rely strictly on verifiable computational work and real-world building activity. Consider how this multi-chain stack functions during a fully autonomous treasury management operation. First, the AI securely receives verified external market data via the Flare network. It processes this information and finalizes a trading strategy entirely inside a confidential compute enclave to protect the proprietary model. Next, the AI instantly executes the asset swap on the Xrpl's native DEX, while simultaneously logging an immutable cryptographic audit trail on the Hedera network. As these systems scale, humans will likely interact with this complex architecture through digital economic entities, like the MB589 and MG589 frameworks, which function as recognizable interfaces for managing autonomous machine activity. Web3 is transitioning from a series of isolated human communities into an interconnected operating system built for autonomous machine coordination.